Today in this video, I am going to explain how to solve trigonometrical sums based on addition and subtraction formulae. Addition and subtraction formulae in trigonometry are sin A plus B is equal to sin A cos B plus cos A sin B. Sin A minus B is equal to sin A cos B minus cos A sin B. Cos A plus B is equal to cos A cos B minus sin A sin B, and cos A minus B is equal to cos A cos B plus cos sin A sin B. Tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B, and tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. These are called addition and subtraction trigonometrical formulae. So we are going to solve some of the sums based on these formulae. So we have taken first question as prove that first part sin A plus B into sin A minus B is equal to sin square A minus sin square B. And the second one is cos A plus B into cos A minus B is equal to cos square A minus sin square B. In some of the books, these are given as standard relations, that is a standard formulae, these two equations. But in most of the books, these are not considered as the standard formulae. So we have to prove them. So let's start with first one. First is sin A plus B into sin A minus B is equal to sin square A minus sin square B. So let's take left hand side is equal to sin A plus B into sin A minus B. So here we have to use the formula sin A plus B. So as we know, sin A plus B is equal to sin A cos B plus cos A sin B. So write it down, sin A cos B plus cos A sin B, bracket close. Now the next one is sin A minus B. So the formula of sin A minus B, as you know, sin A is cos B minus cos A sin B. So in the second bracket we write sin A cos B minus cos A sin B. So here if you see, sin A cos B is the first term in the first bracket and same term is there in second bracket, sin A cos B. So sin A cos B, sin A cos B, identical terms. Cos A sin B, the second terms are also identical, cos A sin B, cos A sin B, cos A sin B. But the difference is that there is minus in place of plus in the first. So in the first bracket there is plus sign and in the second one is minus sign. So that means we may use the formula A plus B into A minus B, which is equal to A square minus B square. So we may apply that formula and we may write it as sin A cos B square minus cos A sin B square. So we have used the formula A plus B into A minus B is equal to A square minus B square, and we have written this. So as we know that this may be written as sin square A into cos square B minus cos square A into sin square B. Now the next step, sin square A is written as it is, and we know that cos square theta is equal to 1 minus sin square theta, so we may write cos square B as 1 minus sin square B. So 1 minus sin square B is written in place of cos square B. In the same way, minus cos square A may be written as 1 minus sin square A and sin square B as it is. So now we have to open this bracket, so sin square A will multiply both the terms. So we have sin square A into 1, that is sin square A, minus sin square A into sin square B. So we may write sin square A into sin square B and minus sin square B. Here be careful about this minus, because if you open the bracket, so sign of both the terms will change because of this minus. So minus plus minus sin square into 1 sin square B, and minus into minus plus sin square into sin square B, sin square A into sin square B. Now if we observe attentively, we see these two terms are identical, having opposite signs. This is negative sin square A sin square B, and this is positive sin square A sin square B. So these are cancelled with each other, and we are left with only sin square A minus sin square B, which is equal to right hand side. So we have proved that sin A plus B into sin A minus B is equal to sin square A minus sin square B. In the same way, we may prove cos A plus B into cos A minus B is equal to cos square A minus sin square B. So you better try the second one yourself. Now the next question we have taken as proof that cos 9 plus sin 9 upon cos 9 degree minus sin 9 degree is equal to tan 54 degree. So let's prove. Here it's better to take right hand side common out of it, or we may prove it in both the ways. We may prove it while taking the left hand side or right hand side. So let us prove it from left hand side first. Cos 9 degree plus sin 9 degree divided by cos 9 degree minus sin 9 degree. Here if we divide numerator and denominator by cos 9 degree, because this is rule that any expression, any fraction may be multiplied and divided with the same number or same expression. So numerator and denominator of any fraction may be multiplied or may be divided with the same number. So we are going to divide numerator and denominator by cos 9 degree. Be careful, by cos 9 degree. So if we divide numerator by cos 9 degree, the first one becomes 1 because cos 9 degree will cancel cos 90 degree, and the second one sin 9 degree divided by cos 9 degree may be written as tan 9 degree divided by. In the denominator, if we divide by cos 9 degree, the first term again 1 cos 9 degree upon cos 9 degree, and minus sin 9 degree upon cos 9 degree, again tan 9 degree. So here we may write dividing numerator and denominator by cos 9 degree. Here the operation we have carried out in this we have written on the right hand side. So now 1 plus tan 9 degree as it is upon 1 minus, as you see, tan 9 degree may be written as 1 into tan 9 degree. Clear? Next thing is, as we know well, tan 45 degree is equal to 1. So we may replace 1 by tan 45 degree anywhere we want. So we replace 1 by tan 45 degree in these two places. At this one and this one should be replaced by tan 45 degree. So what happens? Tan 45 degree plus tan 9 degree upon 1 as it is minus, replace this one by tan 45 degree into tan 9 degree is equal to, as you know well, tan A plus tan B upon 1 minus tan A tan B is equal to tan A plus B, because the angles are same. Tan A, that is tan 45, tan B, that is tan 9 upon 1 minus tan A tan B, tan 45 tan 9. So the same format of tan A plus tan B upon 1 minus tan A tan B, so we may use that formula. So tan A plus tan B upon 1 minus tan A tan B is equal to tan A plus B, so we may write it as tan 45 degree plus 9 degree, and that is equal to tan 45 degree plus 9 degree 54 degree. So which is equal to right hand side. So we have proved cos 9 degree plus 9 degree upon cos 9 degree minus sin 9 degree is equal to tan 45 degree. Now the next sum we have taken as prove that tan 13 minus tan 13 theta minus tan 9 theta minus tan 4 theta is equal to tan 13 theta into tan 9 theta into tan 4 theta. This is our next sum and we have to prove it. Prove that. So let's start. As we know that well, tan 13 theta may be written as tan 9 theta plus 4 theta, because 9 plus 4 is equal to 13. So tan 13 theta may be written as tan 9 theta plus 4 theta. Now here tan 13 theta as it is, on the right hand side we may use tan A plus B formula. So as you know that tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B. So we may write it as tan 9 theta plus tan 4 theta upon 1 minus tan 9 theta into tan 4 theta. Now transposing the denominator to left hand side, it will multiply tan 13 theta. So tan 13 theta into 1 minus tan 9 theta into tan 4 theta is equal to tan 9 theta plus tan 4 theta. Now opening the bracket, if we open this bracket, the tan 13 theta will multiply both the terms. So we have tan 13 theta into 1 as tan 13 theta minus tan 13 theta into tan 9 theta into tan 4 theta is equal to tan 9 theta plus tan 4 theta. Now if we're transposing these two terms on left hand side, these two terms become negative on transposition, and transposing this term to right hand side, it becomes positive. So we have tan 13 as it is, tan 13 theta as it is. Transposing tan 9 theta to left hand side, it becomes minus tan 9 theta. Similarly, tan 4 theta becomes minus tan 4 theta is equal to, and transposition on transposition this term becomes positive. So we have tan 13 theta into tan 9 theta into tan 4 theta. So we have proved tan 13 theta minus tan 9 theta minus tan 4 theta is equal to tan 13 theta into tan 9 theta into tan 4 theta, which was to be proved. So this is the way to prove this. Now we have taken the next example as prove that, I forgot to write prove that cosec A plus B is equal to sec A sec B cosec A cosec B upon sec A into sec cosec B plus cosec A into sec B. So let's start. So cosec A plus B, as we know that the cosec is the reciprocal of sine, so cosec A plus B may be written as 1 upon sine A plus B. Now applying the formula sine A plus B, that is sine A cos B plus cos A sin B. So sin A cos B plus cos A sin B. Now in the next step, what we have to do, we write this expression as it is, 1 upon sin A cos B plus cos A sin B. Then multiply the numerator and denominator by this expression which is written in the numerator of right hand side, sec A sec B cosec A into cosec B. Multiplying numerator and denominator with the same expression or same number is a permissible operation in maths. So we are doing so. We are multiplying numerator and denominator by sec A sec B cosec A cosec B. So in the numerator we see this expression will multiply 1 and we get the same sec A sec B cosec A into cosec B. In the denominator, this expression will multiply both the terms. So see, this is very important step. So if you multiply this expression, which is the product of these four trigonometrical ratios, with the first term, as we know that sine is the reciprocal of cosec. So cosec A will cancel sin A, because cosec A may be written as 1 upon sin A and 1 upon sin A from the numerator and denominator may be cancelled. So if you multiply this expression and this term, sin A will neutralize cosec A or vice versa, and in the same way cos B is the reciprocal of sec B. So sec B will neutralize cosec B or vice versa. So what is left? Sin A and cosec A will be cancelled with each other, and cos B and sec B will be cancelled with each other. So what is left? Only sec A and cosec B plus. In the same way, if we multiply this expression with the second term, cos AK will cancel sec A being reciprocal, and sin B will cancel cosec B. So what is left here? Sec B and cosec A are left. So in the numerator we have sec A sec B into cosec A cosec B. In the denominator we have sec A cosec B in plus sec B into cosec A, and that was our right hand side to be proved. So here one thing must be kept in mind, that one may be confused. Here cosec A sec B is written, and in our condition on the right hand side sec B cosec A. So as you know well, the product of trigonometrical ratios is commutative. So we may write cosec A first and sec B second. So this is not difference. We have taken the next example as prove that cot 2a plus tanA is equal to cosec A. So let's start. Left hand side is equal to cot 2a plus tanA. As we know that cot is cos upon sine, so cot 2a may be written as cos 2a upon sine 2a, and plus tan is equal to sine upon cos, so tanA may be written as sine A upon cos A. So if we take the LCM sine 2a into cos A, so if we divide this LCM by sine 2a, we are left with cos A, and cos A will multiply the numerator cos 2a. So we have cos 2a into cos A plus, if we divide this LCM by cos A, so cos A will cancel cos A, and sine 2a will multiply the numerator. So we have sine 2a into sine A in this term. Now in this step, if you observe the numerator, we have cos 2a cos A plus sine 2a sine A. That means the angles are identical. If we consider this as A and this as B, so A and A same, B and B same. So these are the identical angles. So we may apply the formula cos A cos B plus sin A sin B. So cos A cos B, as you know, cos A cos B plus sin A sin B is equal to cos A minus B. Using that formula we may write it as cos 2A minus A upon sin 2A into cos A. That's equal to, as you know, 2a minus a, so we are left with cos A in the numerator and sin 2a into cos A in the denominator. As you see, cos A will cancel cos A from numerator and denominator, and we are left with only 1 upon sin 2a. And as you see, the reciprocal of sin is cos x, so 1 upon sin may be written as cos x, so 1 upon sin 2a may be written as cosec 2a, which was right hand side. So we have proved cot 2a plus tanA is equal to cosec 2a.